To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students. So I'm going to continue with the lesson Current Electricity in the previous chapter. That is the first chapter. We discussed what static electricity and current electricity are. So you can remember when you rub one object with another material. For example, when you rub a PVC pipe with polythene, then the PVC rod or PVC pipe gets charged, and there we call it as electrostatic charges. And these charges can attract tiny pieces of paper or tiny pieces of regiform. And the force that makes this rod that has been rubbed with a cotton polythene sheet to attract tiny pieces of paper is what we call as static electricity. But once you connect that PVC pipe to a circuit, we did an activity in the first chapter, there the charges start to flow through the conductor. And that is when the bulb lights, and we call it as current electricity. So current of electric charges flowing through a conductor is known as current electricity. With that, I concluded the first chapter. So in this chapter, we will consider electricity flowing through conductors. So you all know what electricity is or current electricity is, charges flowing through a conductor. So we will need to discuss a little bit about conductors. That is also something that is familiar to you. Any material that allows current to flow through it is a conductor. So conductors are also matter, therefore they are also made up of atoms or molecules. You all know that. So basically, atoms are the basic building units of matter. So conductors are also matter, so therefore they are also made up of atoms. You have to remember that. So because of that, all these conductors have positively charged protons and negatively charged electrons in them. That is why they are also able to conduct electricity. So with that, electricity flowing through conductors. So under that we'll be discussing about conductors. Materials that allow a current of electrons to pass easily through it are known as conductors. So you have to consider this sentence first. So here, materials that allow a current of electrons to pass easily. That is important. Now there are some materials, they will allow current to pass but very slowly. So then you can't consider that as a good conductor. So conductors, they allow electrons to pass easily, then we call it a conductor. Now why is this easily allowed? Or why is it difficult for the electrons to pass through? Now like I said, the matter, all substances are matter. Matter is made up of atoms. They also have positive and negative charges. So some matter, the way the charges are arranged, the electrons or charges can flow easily. For example, metals. Metals have free electrons in them. Because of that, current electricity can pass through metals easily. But if you take something like say wood or plastic, that is also made up of atoms, but there the way the atoms are combined or present in that matter, the charges cannot flow easily. So because of that, they are not good conductors, or they do not allow current electrons to pass easily. So that is what you need to understand. So here again, all metals conduct electricity easily. All metals such as copper, aluminium and iron are electric conductors. So you have to remember all these terms. All metals such as copper, aluminium and iron are electric conductors. So they can conduct electricity easily, or current of electrons can pass through them easily. The electrons in the outermost shell of metallic atoms can be easily detached from the atoms. That is what I told you all as free electrons or mobile electrons. So that is the electron present in the outermost shell. You all can remember the structure we discussed in the previous chapter also. In the middle you have the nucleus. Within the nucleus, protons and neutrons are confined. Around the nucleus there are shells or energy level in which the electrons are moving around the nucleus. And the electrons in the outermost shell, usually if we consider K, L, M, N shells, the electrons in the N shell, or it depends on the atom. Now if you take an atom like carbon, carbon only has 4 electrons. So you know the electronic configuration 2, 6. There are electrons only in 2 shells. So the second shell becomes the outermost shell. So there electrons from the second shell can move. You all know graphite is a good conductor of electricity. So they are the electron in the second shell. But for metals like copper, aluminium and iron, again there are different number of electrons. So they are arranged in shells, and the electrons in the outermost shell can be detached easily because they are far away from the nucleus. Usually there is an attraction between the positively charged nucleus and the electrons. So that is why usually it is difficult to remove the electrons from an atom. But here in metals, the outermost electrons can be detached easily. A large number of such detached electrons from the outermost shell of metal atoms are in random motion in the regions between metal atoms as shown in figure. So if we look at the figure here, you all can see, students, this is a metal structure or what we call as metallic lattice. You all can remember that term also. So here you can see these are the atoms, the positive charges. It's not the nucleus, it is the atom. Here you can see because they are positively charged, because electrons are removed, they become metallic ions. Not the nucleus, it is the metallic ion. So the nucleus and the energy levels, not the outermost energy level but the other energy levels. So it is a metallic ion. Why? They are all positively charged. And all the electrons that come off the outermost shell, they become the free electrons. Here you can see these yellow color dots are the free electrons. So in this structure, the metal structure, the positively charged metallic ions are fixed. They become point charges, and between all these positively charged metallic ions, these free electrons can move around. They can move freely. So they are mobile electrons, movable electrons. Free existence of electrons in the outermost shell of metallic atoms. That is how a metal is made, or that is how a metal is, the structure of a metal. So here you can see if this is a metal rod or a plate of metal, all these electrons, now all the metallic ions, that is the positively charged ions, make the base. That is this yellow color part. But these blue color dots are the free electrons. They move freely or randomly within a metal. But once you connect it to a circuit, if you connect the metal rod to a circuit, then what can happen is these electrons can move in an orderly manner in a particular direction. So then current starts to flow. So for example, if we take a copper rod, initially it will be like that with random electrons. But once you connect it to a battery, And if you have a bulb like that, then what will happen is you will see the bulb light will light, and here you have the battery, and this is a copper rod. Now in this copper rod, here this is the positive terminal of the battery, that is the negative terminal of the battery. What can happen is, now when we say positive terminal, that means there are less electrons there. Negative terminal has more electrons. Now earlier the electrons were randomly arranged there. But what will happen is, because this part is connected to the positive terminal, normally you all know opposite charges attract. So the negative electrons on this copper rod will get attracted to the positive charge. So in this direction, the electrons will start to move. Electrons from the rod will start to move towards the positive terminal. So from the negative terminal also, electrons will start moving like that. So there will be a flow of negatively charged electrons. And the free electrons that were here will start to move in a particular direction. That means an current is flowing in this. So that is what happens here. Current, electricity is flowing here. Now conventionally, always electrons flow from negative charge to positive charge. But the convention is electricity flows from positive charge to negative charge. That is the convention. That is how we understand this concept. So a metal has lot of free electrons, and the free electrons are moving randomly in a metal. Once it is connected to a circuit, they are organized, or they start moving in an orderly manner in a certain direction. So depending on how we connect the circuit, they start flowing in one direction. And that flow of electrons, that is negatively charged particles of a metal, is what we call as current electricity. And electrons flow from negative to positive charge of a battery, whereas current flows from positive to negative charge of a battery, or positive to negative terminal of a battery. This is the introduction, students. I am going to discuss the same concept with a circuit diagram in the coming slides as well. So I am sure you all can understand this concept of conductors. So with that, we will move on to the next slide. The reason for the electricity to flow easily through metals is the existence of free electrons. So here it is the existence of free electrons. Reasons for the electricity to flow easily through metals is the existence of free electrons. So let us consider the process that takes place when the ends of such a metallic conductor is connected to a dry cell as shown in figure. So a metallic conductor is connected to a dry cell. This is what I explained to you all in the previous slide also. So here, now you can see, students, now this is the dry cell. So positive terminal of the cell is on this side, negative terminal of the cell is on this side. And this is the conductor. So like I said, there are more negative charges here, more positive charges here. Now there is free electrons in this conductor. What will happen is, because the negative end is connected here, the electrons will start to push each other in a certain direction. At the same time, electrons will get attracted to the positive terminal there. So they will start flowing in this direction. Direction of flow of electrons. Always direction of flow of electrons. Direction of flow of electrons is from negative terminal to positive terminal. That is important. Electrons always flow from negative terminal of the dry cell to the positive terminal of dry cell. So there are charges flowing, that means there is current electricity flowing through the conductor. So like I explained to you all, if you connect a bulb, then you can see the bulb light. That is because current electricity is flowing. But again, as convention, you have to remember this also. Current flows from positive terminal to negative terminal in a circuit. So that is the conversion. You have to remember that. Electricity or current electricity is flow of charges, and in this it is the electrons that are flowing, but still electrons flow from negative to positive terminal, but the current flow is considered as from positive to negative terminal. I'm sure you all know that. I'm recalling it again and again. I'm emphasizing it again and again so that you will remember that without any confusion. Electron flows from negative to positive. Current flows from positive to negative. So with that understanding, students, we'll move on to the next slide. The negative terminal of a cell has the ability to repel electrons. So to push the electrons away. So here you can see the negative terminal ability to repel electrons. Because there are a lot of electrons, when another conductor is also connected to it, too much of electrons, so they start repelling the electrons, or they start pushing the electrons away. The same time, positive terminal has the ability to attract electrons. So positive terminal attracts the electrons, negative terminal pushes the electrons away. So the electrons start flowing from negative terminal to positive terminal. Therefore, whenever the positive and negative terminals of a cell are connected by a conductor, electrons begin to flow from the negative terminal of the cell to the positive terminal via the conductor. This is what I explained to you all. So you can see electrons begin to flow from the negative terminal of the cell to the positive terminal via the conductor. So that is what I explained. So that is the current electricity or flowing of current through a conductor when connected to a dry cell. Then, this flow of electrons is possible because of the presence of free electrons in metals. So it is possible because of the presence of free electrons in metals. That is, the free electrons that are in random motion in a metal begin to move from the negative terminal of the cell to the positive terminal along the same direction as a result of connecting the electric cell. So this is all what I explained to you all with the diagram in the slide. So I am sure you all have a good understanding as to the current flowing through a conductor and why metals are good conductors. And always remember, electrons flow from negative terminal to positive terminal. Why? Negative terminal has the ability to repel electrons, same charges, and positive terminal attracts electrons, opposite charges. You all have to remember that. So always electrons flow from negative terminal to positive terminal. Is that clear to you all, students? I'm sure it is. So with that, I'll move on to the next slide. The actual flow of electrons takes place from the negative to the positive terminals of the cell via the conductor, what we discussed. However, conventionally, the direction of the electric current is considered to be in the opposite direction to that of the electron flow, what I told you all several times before. That is, when an electron current flows from the negative to the positive terminal, a conventional electric current is said to flow from the positive to the negative terminal. The directions of the electric current flow and the electron flow are illustrated in figures. So there is a figure drawn. At the same time, I will draw that here as well. So here we have a dry cell, and let's say we have a bulb, and this is a conductor. So this is the positive terminal, this is the negative terminal. Here electrons will flow in this direction. Electron flow from negative to positive. But the current flows in the opposite direction. The convention. Current flows in the opposite direction. Current flow positive to negative. That is the convention. Electrons flow from negative to positive, whereas current flows from positive to negative. Current flow is from positive to negative. Is that clear to you all? This is something you all have to remember. And here we have a bulb, so you will see the bulb light. Then you know that current is flowing, and for the current flow, it has to be a complete circuit. And when you all draw also, this has to be a complete circuit. Is that clear to you all, students? So we have the conducting wires, the dry cell, the bulb, and you all should remember electrons flow from negative to positive. Why? The negative terminal repels electrons, positive terminal attracts the electrons. So electrons flow, electrons are negatively charged, so charges are flowing. When a current of charges start flowing, we say there is current flowing. So that is current electricity. But by convention, the current flow or the current electricity flows from positive to negative terminal of the circuit. This is very, very important. I am sure you all can understand that. So with that, students, I'll move on to the next slide, where, like mentioned here, the diagram is given. So you have to remember this. This is also very important. The actual flow of electrons takes place from the negative to the positive terminals of the cell via the conductor. However, conventionally, the direction of the electric current is considered to be in the opposite direction to that of the electron flow. That is, when an electron current flows from the negative to positive terminal, a conventional electric current. You have to remember these two terms also. When an electron current flows from negative to positive terminal, a conventional electric current is said to flow from positive to the negative terminal. The directions of the electric current flow and the electron flow are illustrated in figures. That is on the next slide. But I have already explained to you all what happens there and the convention. So with that, students, I will move on to the next slide. The directions of the electric current flow and the electron flow. So this is the first diagram, first figure, where there is a metal conductor. Now here you can see this is a metal conductor, end of the conductor connected to the negative terminal of the cell. So this is connected to the negative. and this side is connected to the positive terminal. So this is connected to the positive terminal, negative terminal. And positive terminal. So can you all see, students? The electrons will start to flow from negative to positive. Why? The negative terminal repels the electrons, positive terminals attract the electrons. So these are the metallic ions in a metal structure, metallic lattice. End of the conductor connected to the negative terminal of the cell. So that's the negative terminal. And end of the conductor connected to the positive terminal of the cell. So that side it is the positive terminal. And here you can see free electron current. So flow of electric current through a conductor. Now this blue color arrow shows the flow of electrons. Blue color arrow is the flow of electrons from negative to positive. Is that clear to you all? So through a conductor, electrons flow from the side that is connected to the negative terminal towards the positive terminal. In the next diagram also, we will try to understand this more clearly. So here, this is a circuit. Now here you can see the battery connected. Here you can see the head of the battery. So that means this is the positive terminal of the battery and this is the negative terminal of the battery. Directions of the conventional electric current and the free electron current. So from the positive terminal, the bulb, the conducting wire is connected to the negative terminal. So you can see here direction of conventional current is in towards this side, that is from positive to negative. Positive to negative. I am writing it again and again, students, so that you will remember very clearly. Whereas direction of electron flow is from negative to positive terminal. So always electrons flow from negative to positive because the negative terminal repels the electrons, positive terminal attracts the electrons. That is happening in a conductor. But as a convention, the conventional current is said to flow from positive to negative through the conductor, not from here to here or not from here to here. Now electrons flow from this terminal through the bulb to the positive terminal. The same way current flow starts from here, from the positive terminal, flows through the bulb and comes to the negative terminal. That is what happens there. There is no current flow between the terminals of the battery. It starts from one terminal, goes through the circuit and comes to the other terminal. Okay, students. So now that you have understood that electrons flow from negative terminal to positive terminal, while the conventional current flows from positive terminal to negative terminal. Now what we will do is, we will go to the lab and we will do a simple activity to observe how electricity flows through a circuit when the circuit is completed. Okay, students. So this is a simple activity. We will do this to understand the direction of current flow and the direction of electron flow. As you all know, when we have a dry cell, I have a dry cell here, there is a positive terminal and the negative terminal. So when there are terminals, the negative terminals, there are more electrons. That is why the negative charge, negative terminal. And in the positive terminal, there are positive charges. So there is a charge difference, a pressure difference that will drive the flow of electrons through the conductor when the circuit is complete. So that is what we call as potential difference. And when there is a potential difference, there is an electromotive force that drives the electrons to flow through a conductor. And always, since there are more negative charges in the negative terminal of the dry cell, that is the power source, electrons will flow from the negative terminal through the conductor towards the positive terminal. But as a convention, we say current flows from the positive terminal through the conductor towards the negative terminal. So electrons flow from the negative terminal through the circuit towards the positive terminal, while the current flows from the positive terminal towards the negative terminal through the conductor. So for this to happen, for the electrons to flow and the current to flow, there should be a complete circuit. Now here I have the dry cell. The positive terminal is connected to this terminal of the bulb. This part is connected to the other terminal of the bulb, but here the circuit is not complete. So you don't see the bulb light because there is no current flowing through it. So now I'm going to connect this terminal to the negative terminal of the dry cell. Then you have to look at the, here you can see. Can you all see? The bulb lights. So now the circuit is complete. So from the negative terminal of the battery, the electrons flow through the circuit to the positive terminal. Whereas current conventionally flows from the positive terminal through the conductor towards the negative terminal of the battery. So that is how current electricity flows through a circuit. You need to have a complete circuit, and always electrons flow from negative terminal through the circuit towards the positive terminal of the battery, and the conventional current flows from the positive terminal through the conducting circuit towards the negative terminal of the battery. So that is a complete circuit, and there is electric current or current electricity flowing through it. Okay, students. So now that you observed how current flows through a circuit, a very simple circuit with one bulb and a battery, I will move on to the next slide. Okay, students. So here first look at the two diagrams. Now these are two instruments. One is an ammeter and this one is a digital multimeter as an ammeter. So here you can see the symbol A and you can see the indicator, and here also this is a digital one. So you can directly get the value there. That is also used as an ammeter. Now this is an instrument that is used to measure the current that flows through a circuit. So always for a quantity, you all know there has to be a unit. And the standard unit of measuring current is amperes. And the instrument used to measure this current is what we call as an ammeter. So if I go up there, the SI unit used to measure the electric current is known as the ampere. Ampere, capital A. The instrument used to measure the electric current is known as the ammeter. So here it is named after a scientist, so we use the letter capital A as the unit, amperes. 1 ampere, 2 ampere, capital A. And these are the ammeters. You all have to know that. And always these ammeters are connected serially in a circuit. It has to be a series connection. So you have to remember that an ammeter should be connected in series manner to measure the total current flowing through a circuit. Through a circuit. So an ammeter should be connected in series manner to measure the total current flowing through a circuit. So that is the introduction to ammeters, electric current. With that, students, I'm going to move on to the next slide and we will continue with the discussion. So if we need to measure the current flowing through a conductor, it is necessary to connect the ammeter to the circuit in such a way that the entire current passing through the conductor passes through the ammeter as well. So here the important thing is the entire current passing through the conductor passes through the ammeter as well. So that is the reason. Now if you look at this circuit, here you can see this is a switch, then we have the dry cells, 2 cells connected, and here also you can see positive terminal, negative, then the positive of the second cell with the negative. So that is the connection of 2 dry cells to the circuit. Then we have the ammeter there. Now you can see here, students, the negative terminal of the dry cell is connected to the terminal of the ammeter. The other one is connected to the bulb. Now we need to measure the current flowing through the bulb. So the bulb and the ammeter are connected one after the other, joined together. So that is what we call as the series connection. So then only, now current you all know will start flowing from the positive terminal this way through the switch. When the switch is on, current starts flowing this way, goes to the bulb, and the entire current enters the ammeter. Then it flows back to the negative terminal. So that is how we connect an ammeter in order to measure the current flowing through a conductor. So here the conductor is basically the bulb, or else you can have another conductor as well. So if we need to measure the current flowing through a conductor, it is necessary to connect the ammeter through the circuit in such a way that the entire current passing through the conductor passes through the ammeter as well. Okay, students. So now that you have understood how we are supposed to connect the ammeter should be connected in a way that all the current that flows through this bulb flows through the ammeter. That is, if you want to measure the current flowing through the bulb. So let's go to the lab and do this activity and measure the current flowing through the bulb. Okay, students. Now I'm going to do this activity to observe how an ammeter needs to be connected to a circuit in order to measure the current flowing through the circuit. So firstly, you all know there needs to be a power source. So here I have 2 dry cells. Now you all know dry cells have the terminals positive and negative. So when you connect the dry cells, positive terminal, negative terminal, then the positive terminal of the next dry cell and the negative terminal. Then to the positive terminal of the dry cell, I have connected the switch there. So you all know this is a switch you can use to on and off the current flow. So switch, and then it is connected with the bulb, and there from the bulb a wire is connected to the positive terminal of the ammeter. Now this is an ammeter. You can see the A indicated there. Now you all know current flow or current is measured in amperes. Amperes is the SI unit, capital A, and the instrument is ammeter. So that is indicated with that capital A there. Then the negative terminal of the ammeter is connected to the dry cell. Now in this circuit, you can see, students, the current flows through this red color wire to the terminal of the switch. From the other terminal of the switch, you can see there is a connection to the bulb. From there to the ammeter, again back to the dry cell. So it is flowing continuously. This type of connection is known as a series connection. Now all the current from the dry cell, all the current that flows through the bulb flows through the ammeter. Then only you can measure the current flowing through the bulb. That is how we are supposed to connect the ammeter. It is known as the series connection. Now when I switch on the switch or close the switch, you have to observe the light bulb and the ammeter reading. Now I am going to close the switch. Now it's on. Circuit is complete. So here you all can see, students, the bulb lights and also you can see the ammeter reading. Since I have connected to this terminal, you have to look at the bottom reading. So 0.2, 0.2, then it is 0.3 amperes. So the current flowing through the bulb and the ammeter, the same current, that is equal to 0.3 amperes. So that is how you read the ammeter, and that is how we determine or measure the current flowing through a circuit. All the current that flows through the bulb flows through the ammeter as well. That is very important. I am sure you all can understand how we are supposed to connect the ammeter to a circuit. So with that, I'll off the switch or open the switch. So there is no current flow. Then here you can see it comes to 0. So because there is no current flow, the bulb does not light, and also there is no ammeter reading, or it shows 0 reading. So that means there is no current flow. Okay, student. So you're familiar with how to connect ammeters to a circuit in order to measure the current. It has to be connected in such a way that all the current that is flowing through the device that you want to measure the current flow, so all that current flows through the ammeter as well. So this particular connection is something that will be known as series connection. I am sure you all can understand that clearly. With that, I will move on to the next slide. That is an exercise given in your textbook. Mark the currents flowing through the circuits given below by arrowheads. So they want you to mark the currents. Now here, like I said, or you from the diagram you can see that's the positive terminal and the negative terminal, and that is a bulb. So how does the conventional current flow? From the positive terminal to the negative terminal. So if you are to mark with arrowheads, it's going to be this way. Starting from the positive terminal, it comes through the conducting wire, goes through the bulb, again the conducting wire up to the negative terminal. I am sure you would also can do it on your own correctly. The same way, now if we take this one. Now let's say 2 amperes of current is flowing. Now here what will happen is the current that comes. Now current can be indicated using the letter I. Ampere, capital A, is the unit, SI unit. Current is indicated using the symbol I. I current. Or else you can use simple I also. That is also current. So here all the current flows through this one bulb because there is only one bulb. But if you look at the second circuit, now here also this is the positive terminal, negative terminal. So current starts to flow from the positive terminal, the conducting wire, up to this point. But at this point, here, now there are 2 paths. So what will happen is the current will divide. Now we have not discussed about resistance as yet, but you have to remember, students, current prefers to flow through a path that has less resistance. So if we assume that both these paths have equal resistance, both of them, let's say if I put this as B1 and this as B2, B1 path and B2 path, both of them have equal resistance. Then of course, current will divide equally. So here, if both bulbs have equal resistance, then the current divides equally. Otherwise, it will divide according to the resistance. So what will happen is current will divide this way and this way. So the current flowing through this bulb will go here and here, both currents. Now the current flowing through this goes through this bulb, here this way. They will again meet at that point. And finally, it will flow back to the negative terminal. Is that clear to you all? So it will start flowing from the positive terminal. It will come to this point where the current divides to both the bulbs, and then it flows through bulb 1 and bulb 2, and again at this point the current combines. So here current combines. Current combines again and then flows back to the negative terminal. That is how the current flows through this circuit. You all have to remember that. And also students, you all have to remember when current gets divided, more current flows through the path with less resistance. So students, like I said, we have not discussed resistance yet. You may be familiar with the concept, but since we saw the current dividing into parts, I have introduced this concept to you all. Always current prefers the less resistance path. So if there is a path that has less resistance and more resistance, more current will flow through less resistance path and only less current will flow through more resistance path. So you have to remember that. And if the resistance are equal, then of course the current will divide equally. And then again they will meet at this point where the two conductors meet. At this point the current divides, and at that point the current joins again, combines and flows back to the battery. So if you want to measure the current flowing through the full circuit, where will you connect the ammeter? You have to have the ammeter somewhere here. And if you want to find the current flowing through bulb 1, you have to have the ammeter here. If you want to find the current flowing through bulb 2, you have to have the ammeter there. I will show you all using the diagram. So this is the circuit symbol for ammeter. B1, B2, A1, A2, A3. A circuit symbol for ammeter. So here I have connected 3 symbols. Why? Like I told you all students. Now current starts flowing this way, positive and negative, and here at this point the current divides. So current flowing through B1 will be read or detected using ammeter 1, A1. Current flowing through B2 will be read using or can be measured using ammeter 2, A2. But then again, both the currents join at this point. So the current flowing through the circuit, total current, can be measured using ammeter 3. You have to remember that also. So if you remember, we said ammeter has to be connected in such a way that all the current should be measured. So here this is to measure all the current, but if you want to see how much of current is flowing through B1 and B2, this is how you will have to connect it. So if I write that down. Current flowing through B1 is measured by A1 ammeter. Then current flowing through B2 is measured by A2 ammeter. And the total current flowing through the circuit is measured by A3 ammeter. So you have to remember that, students. When we have a circuit, now this is again related to this question where we were supposed to indicate the current flow using arrows. So since here there is only bulb, no problem, all the current flows through the whole circuit. But here of course there are 2 bulbs, so the current divides. So based on that only I have given this explanation. Like I told you all, if the resistance are equal, current divides equally. But if the resistance is different, accordingly current will divide, and also more current will flow through less resistant path. So if we have a circuit like that, you can see when current gets divided, more current flows through the path with less resistance. So again, if we have a circuit like that, you have a circuit where the current divides B1, B2, bulb 1, bulb 2. So if you want to find the current that is flowing only through bulb 1, because the current has divided at this point, you need to have separate ammeters. So A1 will measure the current flowing through this, A2 will measure the current flowing through bulb 2, and A3 you can measure the current flowing through the full circuit. Is that clear to you all, students? So that is what I have written here as well. Current flowing through B1 is measured by ammeter 1, A1. current flowing through B2, that is bulb 2, is measured by A2 ammeter. And the total current flowing through the circuit is measured by A3 ammeter. So this is how the ammeter has to be connected. So now you all are familiar with what current electricity is, and then you all know when current flows, it can be measured, and the SI unit of measuring current is amperes, capital A, and the instrument used to measure current is ammeter. And also in the previous slide, I showed you all using the letter I. It can be either capital I or simple I to denote the current flow. And also you all know the conventional current flows from positive terminal of the battery through the circuit and the conductors to the negative terminal of the battery. And when there are bulbs or instruments connected in this manner, current divides. And it divides based on the resistance of the path. Like I said, if the resistance is equal, current divides equally. So if we need to measure the total current, you have to have the ammeter in a place where the total current flows through it. That is how you should connect the ammeter. And if you want to find the current flowing through each device here, let's say the bulb or some other electric device, then you need to have different ammeters. So that is what we have discussed so far. With that, students, I am going to end this chapter, and in the next chapter, I will discuss what potential difference and electromotive force is, and thereafter we can continue with the lesson.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.